Hi, Algebra 2. This is Unit 12, Lesson 4, Conditional Probability. So conditional probability is basically when one event depends on another event already happening. So the way we notated it is P, probability of A given B. This means the probability of event A after event B has already occurred. So when we have that, see how it's probability of A given B has already occurred, the probability of B becomes the denominator. So note that. That second thing, that's the denominator. And the top, the numerator, is just the probability of A and B. So basically, it's a probability of A and B over the probability of B. B has to happen first, so that's the sample space. That's the denominator for that conditional probability. So we're actually going to start off by looking at a problem that we talked about in yesterday's lesson. So this is a chart that has graduating seniors and their plans, whether they're going to college or not going to college. So remember, M is male, F is female, C is going to college, and N is not going to college. If a person was picked at random, what's the probability that the person was female? So I'm going to look at the total female right here, which is 22. And the total number of people, which is 52. So the probability of getting a female is 22 over 52. And I can reduce that, but I certainly don't need to. Probability of going to college. Well, the total number of people going to college is 29. And again, the total people is 52. So 29 out of 52. So now let's do that conditional. Going to college given they are female. All right, so I basically have 22 female, and out of those 22, 9 are not going to college and 13 are going to college. Okay, and so I'm putting the 13 in the overlap because the second circle is going to college. Now the total number of people going to college is 29, so 13 of those 29 are female, the other 16 are male. So let's figure out going to college given they are female. So that's the number of college and female over the number of female. Remember this F right here, that's always going to be my denominator. Okay, so the number of college and female is 13, and the number of female is 22. So that's my probability. So the numerator is the college and female, which is 13, and the denominator is the total number of female. So which is more likely, that a person picked at random will be going to college given they are male, or that a person will be male given they are going to college? So notice it matters the order in which I'm writing this. So in this first one, this M is my denominator. Okay? So that's going to be my denominator. So let's look at the total males are 30. And my numerator is going to be probability of college and male. College and male is 16. And then I'll put that in my calculator just because it's a little bit easier to compare them if they are decimals. So I actually shouldn't write the equal sign. All right, I'm just going to write it's approximately 0.53 because I'm going to round that off. Okay, and now how about the probability that they are that a person will be male given they are going to college? So C, that's going to be my denominator. So the number of people going to college is 29. I just looked up at the table, and the numerator is male and college, which is 16. And 16 over 29 is about 0.55. So it's more likely they are male given they are going to college. So basically that second one, because 0.55 is higher than 0.53. All right, let's look at a few more problems, make sure that we get this. In a school of 1,200 students, 250 are seniors, 150 take chemistry, and 40 are seniors who are taking chemistry. So let's draw a Venn diagram for this. All right, so I got my two circles, I got my seniors and my chemistry. So seniors are going to be on the left, and chemistry is on the right. So I have 250 seniors, but I'm not going to write 250 in the circle because out of those 250, 40 are taking chemistry. So I'm going to write 40 and 210. And then chemistry, there are 150 taking chemistry, but 40 are seniors, so I'm just going to write 110 over there. All right, so what's the probability that a randomly chosen student is taking chemistry given they are a senior? So probability of chemistry given they are a senior. Well, that's the number of ways I have chem and a senior over the number of seniors. Because remember, this is my denominator. Well, let's look at the number of chemistry and seniors. There's 40 of them. And the total number of seniors is 250. And there's my answer. Okay, so it's not too bad. All right, next example, I have a survey relationship between hair color and eye color. So I have people who have black hair, blonde hair, red hair, and then I have eye color blue, brown, and green. So let's find the probability the person picked had brown eyes given they had blonde hair. So this right here is going to be my denominator. So it's the number of people that have brown and blonde over the number of people that have blonde. All right, so brown and blonde, let's just look at my table, is right here. Brown and blonde is 0.10 over the total number of people that have blonde, which is 0.35. And I'll put that into my calculator. And remember, when you put that in your calculator, you can do 0.10 divided by 0.35, and then I can change it back to a fraction. I hit that math button. So 2/7, or it was 0.29. All right. Find the probability the person had red hair given they had green eyes. So that's the numerator is going to be red and green, the number of people that have red and green over the number of people that have green, because this is my denominator. So red and green. So let's go up to my chart. Red and green is 0.15 over the people that have green, and that's 0.25. Again, put it in my calculator. It's 3/5 or 0.60. Does having red hair seem to have some dependence on having green eyes? How can you tell? Well, I would say yes, it definitely has, because the probability of just having red hair is 0.20. The probability of having red, given that they have green eyes, is 0.60. All right, so a person is 3 times more likely to have red hair if they have green eyes. Versus the overall population is just 0.20. But the probability that they have red hair, given they have green eyes, is 3 times higher. It's 0.60. All right, and that's it for that lesson.